What's up guys, welcome back to another video here at Achieve Academy, and today we'll be going through gradients of lines. Please like and subscribe if you haven't already, because I promise you it is this easy. Our learning outcomes for today is to understand how to work out the gradient of straight lines and understand the formulas, and also to solve gradient of lines exam questions. So, what is a gradient? A gradient of a line refers to the steepness of it. The more vertical the line, the steeper the gradient, the more horizontal the line, the lower the gradient will be. We can work out the gradient by using a formula. In this lesson, we will focus on solving gradient of a line exam questions by understanding the formulas we need to know. Now, let's have a look at an example of gradient of lines. As we said before, the gradient of a line is the measure of the steepness of the straight line. The gradient of the line can either be positive or negative and does not need to be a whole number. If the gradient of the line is in an uphill direction, it is positive, and a downhill direction is negative. The way we work out gradients is by picking points on the graph where the line intersects its whole numbers. This is the easiest way to do it, such here as 0, 0 and 3, 0. Then we use the formula of y over x, but remember it as rise over run. So, we have risen 3 to get from the x-axis up to 3, and we've ran from 0, 0 to 0, 2. So we've made a triangle here. So we've gone 2 across and 3 up. Then we use our rise over run, which is y over x. So we get the gradient of the line to be 3 over 2. Once again, it's that time to have a go at some Maths Genie exam questions. Have a go, pause the video and unpause when you've done. So in our first question, the line L is drawn onto the grid below. Find the gradient of line L. So here we look at where the line intercepts at whole number points. And we can see at the top is 2 and 5 and 1 and 2. So we're going to draw a line down from 5 all the way to 2 and then from 2 all the way to 1. Now we've made our triangle. Don't worry, you can do this with any other points. You could do this, say, at 0, minus 1. Just make sure you've made a triangle, because they will all be the same gradient. Now we've gone 3 down and 1 across, so we do rise over run, y over x, so 3 divided by 1 gets you to 3. Now in our second question, the line L is drawn on the grid below. We also have to find the gradient of this line L. So I've picked the point at the very top, so I've used 5, all the way down we go to 2, and we go from 2 all the way across to 0. So we've gone 4 down, and we've gone 2 across. So we do 4 over 2, which gets us to 2. So, when we're dealing with two coordinates of which we need to find the gradient of the line, we use this equation. Gradient equals y2 minus y1 divided by x2 minus x1. Because your first bracket is x1, y1, and your second bracket is x2, y2. Some questions will ask you to find the value of the coordinate when it gives you the values of the gradient. So you must rearrange the gradient formula to find the missing value. Say, if x2 was given as k, you'd have to rearrange the formula, if you got given the gradient to be 5, to work out what k equals in this instance, because you'll be given all the other values to do so. Here are some more exam questions for you to have a go at. Have a go, pause the video, and unpause when you've done. So, in our first question, we have to find the gradient of the line that passes through 2, 1 and 5, 10. So we use our equation of gradient equals, and then we do 10 minus 1 divided by 5 minus 2. Which is the same as 9 over 3, which is 3. So our final answer is just 3. In our second question, we have to find the gradient of the line that passes through 5, 4 and 7, 0. So we write 0 minus 4 divided by 7 minus 5. This gets us to negative 4 over 2, which is the same as writing minus 2. So our final answer for that is minus 2. Now in our final question, we have to find the gradient of the line that passed through minus 3, 4 and 5, 8. So we do 8 minus 4 and 5 minus 3, which is 5 plus 3. So it's 4 divided by 8, which can be simplified down to 1 over 2. So the final answer is just a half. Now it's time to have a go at some of the hardest exam questions you'll probably be asked on gradient of lines. Have a go, pause the video and unpause. So in our first question, the line AB passes through the point A, which is 2 minus 1, and point B, which is 6, and then K. The gradient of AB is 5. Work out the value of k. So, we use the equation what we did for our last question, but then we have to rearrange to find k. So we do 5 equals k minus 1 over k minus 2. So we get 5 equals k plus 1 divided by 4. So it simply times both sides by 4 to get 20 equals k plus 1, minus 1 for both sides to get k equals 19. So our final answer is 19. In our second question, the line AB passes through the point A, which is minus 3, then 4, and point B, which is k, and 12. The gradient of AB is 4. Work out the value of k again. So here we use 4 equals 12 minus 4 divided by k minus 3, which gets us to 4 equals 8 divided by k plus 3. Now we times both sides by k plus 3 to get 4k plus 12 equals 8. And this can be simplified down to k plus 3 equals 2, because we divided by 4. Then we minus 3 from both sides to get k equals minus 1. So our final answer is minus 1. In our third question, the line AB passes through the point A, which is minus 2, then k, and then point B, which is 4, then 8. The gradient of AB is minus 2. Work out the value of k. So here we have minus 2 equals 8 minus k divided by 4 minus 2, which means minus 2 equals 8 minus k divided by 6. Times both sides by 6 and we get minus 12 equals 8 minus k. Minus 8 from both sides and we get minus 20 equals minus k. Times both sides by negative 1 and we get 20 equals k. So our final answer is k equals 20. And that, ladies and gentlemen, is the end of today's lesson. I did say it was that easy. Thank you very much for watching. Please like and subscribe if you haven't already, and I'll see you in the next one. Goodbye.